The two definitions that you need to know are the standard enthalpy change of solution is the enthalpy change which takes place when 1 mole of a compound completely dissolves in water under standard conditions. The second definition you need to know is the standard enthalpy change of hydration is the enthalpy change which takes place when 1 mole of a compound completely dissolves in water under standard conditions. So the example that's usually shown for this would be KCl solid goes to K plus aqueous plus Cl minus aqueous, which represents dissolving potassium chloride in water. The second definition that you need to know is that the standard enthalpy change of hydration is the enthalpy change which takes place when 1 mole of gaseous isolated ions is dissolved in water to give 1 mole of aqueous ions under standard conditions. A good example of this is gaseous 1 plus sodium ions dissolving in water to give aqueous 1 plus sodium ions. You'll notice that the value of this is negative, which is exothermic, and that's because when you go from the gaseous to the aqueous, the sodium ions are making bonds with the solvent, the water molecules, and bond making is exothermic. So what happens when a compound dissolves? So we can draw a Born-Haber cycle, and two things can be thought to be happening. The first one is that the ionic lattice breaks down. So you can imagine it as KCl solid going to K plus gas and Cl minus gas. And in the second step, there's hydration of the ions. So K plus gaseous plus AQ, which represents the water solvent, goes to K plus aqueous, and Cl minus gaseous plus AQ, which again represents the solvent water molecules, goes to Cl minus aqueous. So from these, you can calculate the lattice enthalpy using a Born-Haber cycle. So on the top line, we have the gaseous ions, K plus gaseous and Cl minus gaseous, and then we have solid KCl on the bottom. Now we know that the lattice enthalpy is the energy released when these ions come together to give KCl solid. So going from here to here, the enthalpy change is the lattice enthalpy. We can also measure this, which is what happens when you take KCl solid and dissolve it into K plus aqueous and Cl minus aqueous, and that's just the standard enthalpy of solution. So as in a Born-Haber cycle you've done before, we want to create a cycle which links this side and this side, and by doing that we're going to change one feature, one state of each of the ions in turn. So going from this line here to this line here, we're taking K plus gaseous into K plus aqueous. And we know, because we've defined it earlier in this, that's the enthalpy of hydration of potassium. The next rung down, which is this one here, is going from Cl minus gaseous to Cl minus aqueous. And we know that that's the enthalpy of hydration of chlorine. We can put numbers into this, which we get from a textbook or a table or a data book. So the enthalpy of hydration of potassium is minus 322 kilojoules per mole. The enthalpy of hydration of chlorine is minus 363 kilojoules per mole. The standard enthalpy of solution, going from KCl solid into K plus aqueous and Cl minus aqueous, is plus 26 kilojoules per mole. And then we can use this information to calculate the lattice enthalpy. So we say that the anti-clockwise arrows, which is this one plus this one, equal the clockwise arrows, this one plus this one. So if you put it in a formula like this, we have this, which is we don't know is the lattice enthalpy, plus this, which is plus 26, equals this one, that one there, plus this one there. And if you rearrange the equation, you can work out that the lattice enthalpy is minus 711 kilojoules per mole.